We are recording. So, base 10 and scientific notation. I want to talk about really big and really small numbers. Okay? Who here has been through chemistry? So you guys should have a good grasp of a really big number. Who can give me an example of a really big number in chemistry, Miss Millis?
The mole.
The mole. What is the mole?
6.02 times 10 to the 23rd.
0.02 times 10 to the 23rd. And this is called Avogadro's number. If I have a mole of a substance, not a little furry thing that makes holes in your lawn that you later want to shoot with your pellet gun, but a mole is a quantity of a substance. If I have a mole of that substance, then I have 6.02 times 10 to the 23rd number of molecules. So if I have a mole of water, how many molecules of water do I have, Mason? That thing right there, right? The audio does not pick up you pointing your finger. I have that many water molecules, okay? Now, the question is, how do I make sense of that number? That is a number. And basically what this number says is I take this 6.02 and Kaya, when I'm multiplying it by this, how many times do I move the decimal point? What do you think, Jasmine? 23 times. Which way do I move it, Sarah? To the right. To the right for the audio recording. To the right. So I take 6, and the decimal point's right there, right? And then 0, 2, and then I take that decimal point, and we're going to try this. Nope, it doesn't work. Okay. Here, we'll do it this way. Point, and then 0, 2. Now let's see if it works. Didn't work.
Make things smaller.
No, that's not going to work either. Here's what see, it works now. There we go. And then 0, 2. And yes! Now, what do I do with the dot? Is I move it once, twice, 3 times. And what goes in there? A 0. A 4th time, and a 0 goes in there, right? And a 5th time, and a 0 goes in there. And a 6th time, and a 7th time, and so on and so on and so on, until I got a bunch of zeros. So riddle me this, Batman. Do I want to write all those zeros? Jared, you're Batman today. Do you want to write all those zeros? No. No, we do not want to write all those zeros. So we come up with a way to shorten out what we write. Because what's Mr. Schultz's axiom? Mathematics. I gotta get my teacher game back. I've been off for a week and a half. I need my teacher game back. Mathematicians are what? Lazy. So we don't want to write all those zeros. I just want to shorten it, and this is how I shorten it. I take some number with a decimal point, and we always write scientific notation with the decimal point right there. Okay? Now this same type of notation works the other way with really, really, really small numbers. I can't think of a number off the top of my head that you might all know that's a really small number. So let's just do this. Let's say I had 1/5 is what in decimal notation? It's 0.2, right? Does everybody agree with that? That's the same as 1/5, yes? Okay. Well, let's take, instead of 1/5, let's take 1 divided by, say, 5 billion. Okay? So now I got 2.0 times 10 to the negative 10. And what does this mean? Well, it means I take that decimal point and I move it how many places, Isabel? How many places am I moving this decimal point right here? 10 places. Which way am I moving it, Nick? To the left. So negative means I move it to the left. Positive means I move it which way, Liv? To the right. See? So this guy gets moved over here. 1, 2, 3. I'm running out of room because I did not plan this well, but this would be 9 zeros, point 9 zeros, and then 2. Why only 9 zeros? Why not 10 zeros in front? Because the 2 is the 10th spot. Right, Andrew? Right. Okay? So this is just an easy way for us to make sense of either really huge numbers or really small numbers. It's nothing more than that. Now, why do I choose 10? Why not choose, I don't know, 7? 6.02 times 7 to the something. Why, Tyler? Oh. Okay. Why do I choose to use 10?
Because it's simple.
What do you mean by simple, Andrew? Oops. What does Andrew mean by simple? I agree with him, but that is what we would call a baseless assertion. Meaning he just had an opinion there, and I agree with the opinion, but what if I didn't? What's his backup? What's his reasoning?
You multiply by 10, you just add 0.
I just add a 0, or I move the decimal point, right? And if I divide by 10, I move the decimal point the other way, right? Good. That sound like something that you had on the tip of your tongue there? That's pretty good reasoning, right? Okay, so here's what I want us to do. On the opening exercise, let's not pay any attention to this stuff, okay? That stuff was from another exercise that we did not do. I just want us to convert 0.28 millionths of a meter to centimeters and express your answer as a decimal number. So let's think about 0.28 millionths. 0.28 millionths. Think about this. If I express that as a fraction right now, what would it be? It'd be 0.28 over what? 1 million, right? That's a million, right? Now, when I'm dividing by a million, which way do I move the decimal point? Left or right? Left. So I take this 0.28 and I move the decimal point to the left. How many times?
Why is it to the left?
Because moving it to the left makes it smaller, right? If I'm dividing by a million, I'm making it smaller, right? Yeah, that's what this means, right? How many times, Liv? 5. 1, 2, 3, 4, 5, 6. I think 6.
But the 2 ways, don't they take up 2 of the 0?
Nope, because remember, this is not 28 divided by a million. It's 0.28. So I start with where it's at, and this is one decimal spot, that's another decimal spot, that's another decimal spot, that's another decimal spot, another decimal spot, and another decimal spot. So I move it to the left 6 decimal places.
What about the 1?
What's something divided by 1? It's just itself, right? Right? So this is going to be 0.000000028. Or, think about this. This is also 2.8 times 10 to the negative what? Negative 6 would give me there. 7. Negative 7. Negative 7.
How'd you get negative 7?
Because of the fact that you have the 6.
I want my decimal point right there, right? And in order to do that, I have to go 1, 2, 3, 4, 5, 6, 7.
Why do you want it in front? Why do you want it in the middle?
I always want my decimal point to be like this.
William,
I want my number here, or I'm sorry, my number right here, I want somewhere between 0 and 10. I don't want it to have no digit over here. I don't want it to have 2 digits over here. That's the standard for scientific notation. Okay? It has to be an integer and then a decimal point, and then it can be whatever afterwards. Yes, sir?
Why is it negative if it's going towards the right?
It's not going towards the right because this is. Wait. Let me get this. I'm finding out. Don't like that. I'm finding out what this number right here is in scientific notation, right? So what I'm doing is I'm figuring out, okay, well, to get this into scientific notation, I have to move this to the right 7 places, right? Hear me out. Hear me out. To get this into scientific notation, I have to move this over 7 places, right? And then to get it back to this notation, I would have to move it to the left 7 places. And that's why this is a negative. Okay? So now, but I really haven't done what it's asking me to do. Haven't done what it's asking me to do. Now I want to convert 28 millionths of a meter to centimeters. This is meters, right? Now, how many centimeters are in a meter? 100. 100 centimeters per meter. I don't know if they taught you this in chemistry, physics, or in physical science yet. So get ready to have your mind blown. Anthony, can you shut that door, please? Thank you, sir. How many centimeters are in a meter? 100 centimeters per meter. Yes? Now, what happens to my meters? They cancel, right? I got a meter in my numerator right here. I got a meter in my denominator right here. Meter divided by meter, they go away, right, Jordan?
Yes.
stoichiometry all over again.
Stoichiometry. Jordan? There we are. You didn't miss much. You did not miss much. Can you hand that back to Jordan, please? Thank you. So, now, the meters cancel out. Now I got to do the math. So think about this. If I'm multiplying by 100, am I moving this decimal point to the right 2 or to the left 2? To the right 2, right? So, times 100. Let's do it up here. We'll do it up here in decimal, and we'll do it down here in scientific notation. So the meters cancel out, and then I'm getting 28 with 4 zeros in front of it. So this is 0.000028 centimeters. Down here, if I'm multiplying by 100, what happens to this exponent? I lose 2 negative, right? So instead of -7, it'll be -5. 2.8 times 10 to the -5 centimeters. Okay? Does that make sense to everybody? 2 different ways to express the same exact thing, right, Ethan?
Yeah, 2 different ways.
It's not always going to be the way you want it to be expressed. That's why we're learning both ways. Okay, now, letter C, match equivalent expressions without using the calculator. So, we've gotten a little basis on what scientific notation means, right? So now, let's figure out which one is which. What do we think? Let's start with 3.5 times 10 to the fifth. So now, I'm taking 3.5, and what am I doing to that decimal point? I'm moving it which way? To the right, Sarah. Good. And how many places, Christine, am I moving it? 5 places. So I take 3.5 and I go 1, 2, 3, 4, 5. So it's 2, 3. So it's 35 with 4 zeros after that. So which one is it? It's the one right below it, right? No. It's this one, right? So there we go. How about negative 6?
6 times the negative 1. No, that would be.
How many times am I moving the decimal point to the left in 6 times 10 to the negative 1? Moving it 1 time, right?
Yeah.
Right? Don't fall into the trap of thinking, ooh, that means it's a negative number. Does that mean that this whole thing is a negative number? No. What does it mean? To the left. Means my decimal point place is moving to the left. Okay? It does not make the number negative. It just means I'm moving the decimal place to the left. To the 0 power. Because how many times am I moving the decimal point? 0 times. Does that make sense to everybody? What is any number to the 0 power? 1. Any number to the 0 power is 1. We learned that in our little day with exponents right before the ACT. Okay? Any number to the 0 power is 1. Save one number. 0. There's no Jesse, my man. Yeah, you can't have 0 to the 0 power. All right. So this guy, I'll do this one in red. This guy and that guy are simpatico. Okay? How about 0.6? Who can give me some input on that one?
That's one I put. That's
The negative.
negative 1.
Ah, this one right here? Yeah. Let's do that one in, should we do that one in green? Let's do that one in green. There we go. I'll buy that for $1. Okay, how about 3.5 times 10 to the negative 6? Which one is that, Mason?
0.6.
The one under 0.6. Oh, down into the left one, right? This one goes to that one? So, right here. Do that one in blue. Good. And then last, my favorite color here. I'll do baby turd yellow. How's that? Do baby turd yellow? Yeah, I know. Yeah. Well, which one is 3.5 times 10 to the 6? Is that the only one that's left over? This one? That's right, isn't it?
Yeah.
There we go. I love that color. I don't know why.
Looks like mustard, like a mustard yellow.
You know what it kind of looks like? It kind of looks like the pea soup days soup.
Well, that's a bit more green.
A little bit. I'll give you that. How about we do that? We're like celebrate Somerset here with some like that. Good enough. Good enough. All right. let's do example 1. All 5 of them. Let me see if you guys got this under wraps here. Everybody do letter A. I'm going to be coming around here and checking. This is not your homework. Your homework's coming up. Everybody do letter A, and I will see if you guys are on point. Let me rephrase the directions. Put into scientific notation. So if I start right here, right, which way do I have to move the decimal point to get that? Right. Yeah, so should that be a negative? Yeah. Remember, to the right is positive.
I thought it was
Yeah. Each number is product of a decimal number between 1 and 10, right? Is that between 1 and 10? Right. How do we do scientific notation? You get this part. You got this part right. Okay. I don't. So, remember, I want this number. This number has to be between 1 and 10. And then I multiply it by a number here to get that. Okay? So how many? So what number would I multiply by a multiple of 10 that's between 1 and 10? Remember, it's going to have the same 3 digits, right? So you want, where's the decimal point need to be for that to be between 1 and 10? Yeah. And then how many times you got to move the decimal point for it to equal it? 5. And which way are you moving? You're moving that way, right? You're taking this, you're moving it that way. So it'd be positive 5.
2 points.
Yep. So it's going to be that number, except with the decimal point in place where it's between 1 and 10. So if I take 2, I'll try and write my 2, 3, right? Where would you put the decimal point? So that's between 1 and 10. Yeah, okay, so put the decimal point there. And now times 10. Now you're going to write times 10. And then how many times do I have to move this decimal point? Now we're going to take that decimal point and we're going to put it right there, right? How many times do I got to move it? So then that's the number of it. Does that make sense?
I'm pretty sure I am.
Yes, yes. Yeah. Yeah. Yep, you want to do scientific notation. What's the exponent on the 10 going to be? Remember, look back to your, beautiful. 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 Wow. You guys are rocking and rolling. You guys are rocking. Came in late, right? That is right. You getting it? Or, well, yeah. You want the decimal point on the front end. Where's the decimal point? No, you're going to want the decimal number between 1 and 10. So where's the decimal point on it? Oh, yeah. Get your racing game up to speed then. Okay, now, times 10. Now, how many times, now let's pretend that that decimal point is right here. How many times you gotta move that decimal point to get it there? 1, 2, 3, right? Okay, move it to a lot. Alright, and that's how
They were also I read those, but they were like 2 months ahead of us.
Word, good. Well, how did we do it? Not 10 to the first. How did we do it here? How did we do that?
That number.
Times 10 to the 0. You bet. All right. So, let's see. Yes. Huh? Huh? All right. So, letter A. 2.34 times 10 to the 5th power. Letter B. 3.5 times 10 to the negative 3rd power. $5.321 times 10 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.2 times 10 to the negative 9th. And then 3.331 times 10 to the 0. Okay? Your homework for tomorrow. Is exercises 1 through 6. Took you guys maybe 2 minutes to do 1 through, or A through E. 1 through 6 are almost that easy. Okay?